In this video, we're going to be talking about descriptive statistics and graphing with categorical variables. So recall with categorical variables, the observations take non-numerical values. So basically, we can't find things like the mean and standard deviation to describe any sort of central tendency or spread. So basically, we have to use other ways of describing the data. And so a lot of times what people do is they use stuff like proportions and counts within categories. So this is an example of a table with a categorical variable. The variable in this case is political affiliation. And so for each of these four categories, so there's a don't know, refuse to answer, Democrat, Independent, and Republican. There's the count for each of these, and then the associated proportion. So basically, this gives us a way of having an analog of central tendency. So basically these proportions are that kind of measure of central tendency rather than using a mean. Right? So for example, if you think about the proportion that is Democrat, that's 0.28. That is kind of like an average of is a person Democrat or not. And so you can kind of think of it that way. This is a bar chart that just kind of shows the values that we were just talking about, the counts, and you can kind of see, relatedly, the proportions, the relative to each other. And so basically, in this data set, it seems like there's a lot of independents, and then Democrat, then few Republicans, and then a small portion said they didn't know or refused to answer. This is a pie chart. It's just another way of showing the data. I'm just kind of showing how much each different category takes up out of the whole, showing those proportions. Now this is here, but don't use pie charts. Basically, the goal of a visualization is to help make the distribution of numbers or categories easier to understand. But humans are very bad at interpreting areas of circles. And so looking at a pie chart, it can be really hard to interpret what the proportion is, to compare wedges to each other, things like that. So all the information that's found on a pie chart can usually just be found just by using a bar chart, just by using numbers, things like that. So usually pie charts aren't very good as visualizations. Right, so many times we're not really interested in just one variable. We're interested in kind of multiple variables about the relationships between variables. So, for example, let's say we want to know whether support for federal funding of scientific research differs by political party. All right, so now we have this contingency table. We have this 2x2 table, or I'm sorry, 4x4 table actually. Basically, on the kind of left side, we have about right, don't know, refuse to answer, too high or too low, kind of referring to the levels of federal funding of scientific research that the people think that there should be. And then on the top you have don't know, refuse to answer, and then Democrat, Independent, Republican. So that represents the political party. Basically within each cell you have just the counts of each of those. So basically on the top left one there's the about right and then don't know, refuse to answer. There were 70 people who answered that they thought the level of federal funding of scientific research was about right, and that they refused to answer what their political party was. And then the next one, 20, is the Democrats who said that the level of scientific research was about right. So just from looking at this, can you tell if they're related or not? Well, just from these numbers, it's really hard to say. Basically, you can kind of see that there's more in certain cells, so you can kind of see, there's more independence, but it's really hard to tell relationships between the two variables just because these are just raw numbers, and it's really hard to kind of interpret it. So what you can do is you can use proportions. And so here what we're doing is we're finding column proportions. And so if you sum down each of those columns, they should add up to 1. So if you look at that second column, Democrat column, so it's 0.23, and then if you add 0.6, 0.06, 0.13, 0.59, that should add up to 1. So here it's easier to compare because we can just kind of move across each of these columns and compare these proportions. And so basically of the people who said that the level of federal funding of scientific research was about right, it seems like kind of disproportionately more of the Republicans said that it was about right. Whereas generally Democrats disproportionately more said it was too low. Right? So you can kind of see that kind of relationship here with the column proportions. Right? And this is just a way of visualizing the relationship between these two variables, and you can kind of see that same thing. So if you look at the about right and the too low categories, you see that green bar for Republicans is much higher for about right, and then for too low, you see that blue bar and that yellow bar actually is much higher for showing that Democrats tend to think that it's too low.